Alright, so in this video, what we're going to do is we're going to investigate solutions to two variable equations. And we're also going to talk about how to, if you wanted to change this to slope-intercept form, like how would you be able to do that? So we're going to use this video to kind of go over a couple of things. Alright, so right now we have an equation here. It says 3x plus 3y equals negative x plus 5y. It says which ordered pair is a solution of the equation. Alright. So right now, we're going to be checking two ordered pairs. We're going to be checking the ordered pair known as 1, 2. And we're also going to be checking the ordered pair 2, 4 to see if it works. So this is your x value, this is your y value, this is your x, and this is your y. Now, check this out. What we're going to do is we're going to go to Desmos, and I'm actually going to go to Desmos test mode, okay? Like if you were taking a STAR test. Now, one thing you are allowed to do in Desmos is you are allowed to type in the ordered pairs. So it's that 1, 2, and 2, 4. So I could type in, technically I could type in a 1, 2, and I could type in a 2, 4. All right, so that's one of the things you are allowed to do in Desmos. You could also make a table and do 1, 2, and 2, and 4. So you could either do it, type them in as a table, or you could type them in individually as an ordered pair. So I'm just going to leave them right here. Now, one thing you'll notice, that says 3x plus 3y equals negative x plus 5y. Well, if I type that in, 3x plus 3y equals negative x plus 5y. Well, this will not work in Desmos when you're trying to take a test. It's got to be in y equals form. So if it has to be in y equals form, what would we have to do? Since I have a little bit of room here, I'll go ahead and change it to y equals form. You don't have to do this for this exercise, but it's always helpful to know how to change things to y equals. There's the equal sign. All right. You'll notice I have 3y's over here and 5y's over here. So since I have more over here, I'm actually going to take away 3y from both sides, which leaves me with 2y. And then if I move all the y's to one side, I have to move all the x's to the other side. So I'm going to add an x. I'm going to add in x, and I get a total of 4 x's. So if I have 4x equals 2y, that's the same as 2y equals 4x. So if I wanted to solve for y, I just have to divide both sides by 2, and y equals 2x. So this is in the form of slope-intercept form of y equals mx plus b. So it looks like our slope, that's not a very good m. Try it again. It looks like our slope of our equation is 2, and our y-intercept is at 0. So right here, there's 0. I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. So you know what? Just by doing this, I can kind of see that, yep, these points would definitely go on that line. So what did we simplify it to? We simplified it to y equals 2x. And you can clearly see that these 2 points right here, that point and that point, are on the line. Now, you don't have to do that for this equation. All right, you don't have to do that. I'm going to show you what they would like you to do, and I'd like you to be able to do it as well. I'd like you to be able to take the equation 3x plus 3y equals negative x plus 5y, and I'd like you to know how to plug these numbers in. So I'm going to highlight them. I'm going to put the x values. Let's see here, what color do I want to use? Let's go x values will be red. Okay. And let's make y values orange. No, not orange, green. All right, let's make them green. All right, so let's check this out. So we're going to do 3 times the x value plus 3 times the y value. And we're going to see if it equals negative times the x value plus 5 times the y value. So what we're going to do is we're going to take a 1 and a 2. We're going to plug it in. We're going to take the 1, plug it in here, take the 2, plug it in here. Take the 1, plug it in here, take the 2, plug it in there. So you'll notice, wherever there was a value of x, what did I do? I plugged in the number 1. And wherever there was a value of y, I plugged in the number 2. So I'm checking this ordered pair. So right now, if you're wondering what I'm doing, I'm checking to see if this ordered pair works. Well, let's see if it works. 3 times 1 is 3. 3 times 2 is 6. 3 plus 6 is 9. Negative times 1 is negative 1. 5 times 2 is 10. Is negative 1 plus 10? That's also equal to a 9. They work. So since this side equals this side, I know that this ordered pair works. So I'm going to do it again, except this time I'm going to do it for the other one. So I'll move over here. I'll do it. I'll make it nice and neat. I've got 3x plus 3y equals negative x plus 5y. And I'm going to do the same thing I did before. Wherever there is a variable, simply going to open up a set of parentheses. But this time I'm plugging in a 2 and a 4. So I'm plugging in a 2 and a 4 and a 2 and a 4. Now 3 times 2 is 6 and 3 times 4 is 12. And I add those together and I get 18. And negative times a 2 is just negative 2. And 5 times 4 is 20. And negative 2 plus 20 is 18. And you can clearly see that 18 is equal to 18, just like 9 was equal to 9. Hold on. 9 was equal to 9. And look, they both work. That means this ordered pair works. Now, remember how I told you they were going to work? Because guess what? They were a part of the line. All right? So if you look at it, you can clearly see if I simplify this by subtracting 3y from both sides and adding x to both sides, I get this equation y equals 2x. By the way, these are the same. This is simplified to y equals form. This is just not changed everything over to y equals form. So what does that mean for us? Well, that means that, hold on, let me see here, right here. That answer works and that answer works. I'm going to choose both. Okay, sometimes neither of them will work and you'll choose neither. All right, here we go. Oh, that's already in slope-intercept form. That's kind of easy, all right? If it's already in slope-intercept form, then you could literally, since it's already in there, hold on, let me try to get to the old Desmos. There we go. Clear that out, clear that out. This will make it kind of easy and fun to do. All right, here we go. Y equals 8x plus 3. So there's a line, y equals 8x plus 3. All right, I'll zoom out a bit. Let's just type in our ordered pairs. Our ordered pairs are 1 and 11 and negative 1, negative 5. 1 and 11 and negative 1, negative 5. 1 and 11. All right, here we go. 1 and 11. That's on there. And negative 1 and negative 5. That's on there. If it's on the line, it works. It's a solution. If it's not on the line, it doesn't work. Look, if I put a negative 6, I zoom out, you can clearly see, oh, that's not, even though it looks like it's on the line, it's not. But a negative 1, negative 5 is. Just like if you put like negative 3, negative 5, you can see that's not on the line. So that's not a solution, but this is a solution. Right there. Now that's not what I want you to be able to do. I want you to be able to simply plug these numbers in and solve for them just by hand without use of a technology. But I wanted to also show you how to use technology to check your answer. By the way, the only reason we could put it into Desmos is because it's in y equals form. So here we go. But y equals 8x plus 3. Now put y equals 8x plus 3. But this time, I'm going to use 1 and 11. I'll do that in red here. Okay, I'll use a 1 and 11. I'll show you how to do it by hand. And over here, I'll plug in a negative 1 and a negative 5. When you're doing this, it's very important that you label it. That's your x and your y. And this is your x value, and this is your y value. All right, so what's my y value? My y value is 11, so I'm going to put 11 equals 8, open parentheses. What's my x value? 1 plus 3. So is 11 equal to 8 times 1, which is 8, plus 3. Yes, it is. 11 is equal to 11, so I know it works. What's my y value? Negative 5, so I'm plugging it in. What's my x value? Negative 1 plus 3. Negative 5 equals negative 8 plus 3. Is negative 5 equal to negative 5? It works. So when you plug it in, one side of the equation is equal to the other side. So once again, both of them work. So I'll put both. They both work. Let's get one. Let's hope that there's one where one of them works but the other one doesn't. So let's try this one. I'm not going to type it into Desmos. I'm just going to do it by hand. Okay. This will be the last one that we do, hopefully. Negative 3x minus y equals 6. Negative 3x minus y equals 6. So once again, I'm going to take the ordered pair. I'm going to check. See if negative 4 comma 4 works. And then over here, I'm going to check to see if negative 3 comma 3. Negative 3 comma 3 works. Once again, I'm going to label my x and my y. Over here, I'm labeling my x and my y. So just as a quick review, you're taking the negative 4 and you're plugging it in for x. And then you're taking the positive 4 and you're plugging it in for y. So over here, I'm taking negative 3, plugging it in for x, and I'm taking positive 3 and plugging it in for y. So here's what it should look like. Negative 3, open parentheses. I'm plugging in a negative 4 minus open parentheses, and I'm plugging in a positive 4 for y. And I'm seeing if it all equals a 6. So here we go. Negative 3 times negative 4 is positive 12. And 12 minus 4 does not equal 6. Because 12 minus 4 is 8. And 8 is not equal to 6. So this answer is not correct. It's not right. I'm just going to put no. That's not it. I know it's not that. So it's either going to be only or it's going to be neither. Let's check out the next one. I've got negative 3, open parentheses. What am I plugging in? I'm plugging in a negative 3 minus open parentheses. What am I plugging in? Plugging in a positive 3. And we're seeing if this is equal to a 6. Negative times negative is a positive. 9 minus 3 equals 6. I like it because 6 does equal a 6. So this one works, but this one does not. So I'm only going to choose answer choice B. Now what I'm going to do, because it's important that you guys know how to solve for y. Okay, let's change it. Let's just solve for y. It's really easy. All right, I'm just going to add a y to this side. I'm going to add a y to this side, and then I'll take away a 6 from this side, and I'll take away a 6 from this side. Now these aren't like terms, so we're left with negative 3x minus 6 equals y. We are now in slope-intercept form. Y equals negative 3x minus 6. If you want to know what your slope is negative 3, which means it's negative, which means it's technically equal to negative 3 over 1, which means I go down 3 and over 1 to the right, and my y-intercept is at minus 6. All right, so check this out. Y equals negative 3x minus 6. So I'll go right over here to Desmos. Okay, and I'll go ahead and delete those. I told you it was y equals negative 3x minus 6. Now check this out. I'm going to go ahead and zoom out just a bit because I want you to see why our answer of negative 3 comma 3 is on the line, but parentheses negative 4 comma 4 is not on the line. So I want you to see how this is a solution, but this is not a solution because it's not a part of the equation. If it's a part of the equation, it's an answer. If it's not a part of the equation, it's not the answer. So that's why I'm only going to choose negative 3 comma 3. So let me go back over here. Negative 3 comma 3. And that's how you do it. Okay? So you plug them in. What do you plug in? You check to see if this ordered pair will plug in to make one side equal to the other side. Hope this was useful.